Hello viewers, in this video I'm going to be showing you how to solve system of equations and using Cramer's rule. You can use Cramer's rule to solve a 2 by 2 matrix, and you can also use it to solve 3 by 3 matrix. So this is a 3 by 3 matrix where we have x, y and z, and if it is 2 by 2 we can only have just x and y and then the right hand side of the equation. So we are going to be solving it and this equation using Cramer's rule. So we take our solution. So the first thing is for us to arrange the values in form of an equation. So because this is x and it's 1, the coefficient of x is 1, so we have 1. Here coefficient of x is 2, so we have 2. Coefficient of x is minus 2, so we have minus 2. Then for y we have 2. Here we have minus 4. And here we have 2. And then for z, the coefficient is minus 1, 1, minus 3. So we are done with that. We put it in this kind of bracket. And then, because we are dealing with x, y, and z, so this will be our x, this will be our y, and this will be our z. And so it is equal to the right hand side of the equation. So we have minus 3, minus 7, and then 4. So we also put it in box. So this is the first step, okay? But if you have a situation whereby the values or any of these values are not given, maybe you have 2y minus z only here and x is not given, it means the value of x there will be 0. Or if you have 2x minus 4y and it's a 3 by 3 matrix and the value of z is not given, and you know that that z here will be 0. So that's how to go about it. So we've been able to do this. Now, in using Cramer's rule, first we have to find the determinant of this matrix. We have to find the determinant of this matrix. When we are done, we find the determinant of x, we find the determinant of y, and we find the determinant of z. And from there, we can find the value of x, y, and z. So let's find the determinant of this matrix first. So we can call this matrix, this one here, we can call it matrix A. So let the determine A, matrix A, equal to what we have here, which is the values here. So this will be equal to 1, 2, minus 2, 2, minus 4, 2, minus 1, 1, minus 3. So this is, let's call it A, okay? And so we know that in matrix, this is plus, this is negative, this is plus. So let's find the determinant for A first. So A determinant, let's make. So if we are to find for the first part, so this is how to find determinant. For 1, considering this 1, so we write 1, then we put it, we close here, and we close here. So when we close here, and we close here, because we are considering 1 now, as the first value is 1, so we close here, and we close this line. So what we are going to have inside will be minus 4 to 1 minus 3. So minus 4, 2, 1, 3. We are done with the first one. So the second one is 2. But note we have negative here from, so we have minus 2 because of this sign here, the normal natural sign or rule you have to consider in a matrix. So for 2, we cross here. Okay, for 2, we cross here. And then we cross here. So when we cross here, we are going to be left with this, and this. So we have 2, minus 2, 1, and minus 3. 1 and minus 3. So we are done with that. And then the last one is minus 1, which is minus 1 here. So we have minus 1. And so we close here. We also close here. So we are left with 2 minus 2. So we have 2 minus 2. That is 2 here minus 2. Minus 4, 2. So we have minus 4. And then 2. Okay. So since we've gotten that, we can now solve it out. So our determinant A now will be equal to, we have 1 into, it will be this times this times this times this first, this times this second, this times this first, this times this second. So that is how the flow will be. So if we say minus 4 times 3 will give us minus 4 times 3 will give us is it minus 4? Okay, sorry. If we close here and close here, okay, this is minus 3. So minus 4 times minus 3 will give us 12. Then 2 times 1 is 2. Or you know you subtract, so it's minus 2. So we have minus 2. We are considering this now. 2 times minus 3 is minus 6. Minus 2 times minus 1 is minus 1. Of course, you know we have another minus, so normally it's supposed to be minus. Then minus 2 times minus 1 is minus 2. So we are done with that one. Minus 1. 2 times 2 is 4. Minus. Minus 2 times minus 4 is 8. Okay. So in this we are going to have 1 into 12 minus 2 is 10. Minus 2 into minus 6 minus minus 2 will be minus 6 plus 2, because minus times minus here is plus. So we have minus 6 plus 2, and that is going to give us minus 6 plus 2 will give us minus 4 minus 1 into 4 minus 8 is minus 4. So this will give us 1 times 10 is 10. Minus 2 times minus 4 will give us plus 8. And minus 4 times minus 1 times minus 4 will give us plus 4. So when we take this, we add this, we have 22. So it means the determinant, of this matrix is 22. So that's the determinant of that matrix. So it's 22. So since we've gotten the determinant of this matrix, we have to find the determinant of A, we have to find the determinant of Y, and we also find the determinant of Z. And then from there we can solve everything down. So let's find the determinant of X. Let AX be the determinant for X. Okay, so we've made that mathematical statement. Let AX be the determinant for X. Now this is the logic. Since we are finding for X, this is the X. Since we are finding for X, we are going to replace the column of this X by this. So which means we are going to bring this, we will take this out completely, bring this down here and find the determinant. If we are doing for Y, we will take this out completely, bring this down here to find the determinant for Y. If we are doing for Z, we will take this out completely, bring this down here. So let's do for X. So for X, we are going to take this out and bring only this one in. So let's find determinant for X. So we are going to take the whole of this out. So So we bring this in here. So x determinant will be equal to, so we take out this value, replace it with this. So we are going to have -3, -7, 4. And we can take this one now. 2 -4, 2. Then we can take this one now. -1, 1, -3. So that's how to go about it. So we can find, note, when you are finding for x, you remove this value of, remove this one entirely and replace it with this, just the way I've done. I've replaced this value now with this, but this, the y and this one remains. So but if I'm finding for y, I'll replace this, the x and z, I'll replace this with this, the x and z remains. If I'm finding for z, I'll replace z with this, the x and y remains. So for x, we replace it with this, and then y and z remain. So let's find the determinant. So for -3, so we have minus, so we have -3. This is -3. We are going to do the same thing. We close here and close here. Okay, we close here and close here. So we are left with -4, 2, 1, -3, minus, this is, we know in matrix, so -2 into, so if we close here, we close here for 2, so we are going to be left with -7. We are going to be left with -7 for 1 -3, -7 for 1 -3. Okay, we are done with that. So for -1 now, so we have -1, which is the last one here. So we close here and close here. So we'll be left with -7 for -4, 2. Okay, so having done that, we can now solve it down. Having done that, we can solve it down. So in solving, we have -3 into, I said this will multiply this first, second, this first, second. So -4 times -3 will give us 12. -2 times 1 is 2. -2 into -7 times -3 will give us 21. -4 times 1 is 4. -1 into -7 times 2 will give us -14. -4 times -4 will give us -16. Okay, this will be -3 into 12 minus 2 is 10, -2 into 21 minus 4 is 17, -1 into -14 minus -16 will be -14 plus 16, and that will give us 2. -14 plus 16 will be 2. So this will be equal to -3 times 10 will give us -30. This one, -2 times 17 is -34. -1 times 2 will give us -2. And so when you solve this, you have -66. So it means our determinant for x equal to -66. So we are done with finding determinant for x now. So we can go ahead to find determinant for y. So we can say let ay be the determinant for y. Let ay be the determinant for y. Okay, like I said earlier in the video, if you want to find determinant now for y, it means that you are going to replace the x will remain, but this y value you are going to replace it with this value, then the z value will remain. So for y, we are going to replace this value with this. So we have x value, replace this with, we replace the y value with this, and then we have the z value. So for y, this is what we are going to have. So our ay will be equal to, we take the x value, we take the x value first. So this is the x value. So we take it to be 1, 2, minus 2. Our y value, this is our y value. We are not going to use it since we are dealing with y. So we replace it with this value. So our y will now be minus 3, minus 7, and then 4. And then our z value will remain. So we have minus 1, 1, and minus 3. So we can now find our determinant. So because I've showed you already, let's go quickly to find the determinant for y. So our ay now will be equal to, when we take 1, and then we close it, we close here, we close here, and close here too. When we close these two, so we are going to be left with minus 7, 4, 1, minus 3. So you know this is positive, negative, positive. So we have negative, but again we have minus 3. So minus 3 into. So we close this and close here. So we are left with 2, minus 2, 2, minus 2, 1, minus 3. We are done with that. We take minus 1, which is the last one here, and then we close here, and then close here. We are left with 2, minus 2, minus 7, 4. That's what we are left with. So let's solve it out. So we have 1 into minus 7 times this will give us 21. 4 minus 4 times this is 4. Minus times minus here will give us plus 3 into this times this will give us minus 6. Minus 6. Minus 2 times 1 will give, okay, minus 2 times 1, minus 2. Minus 1 here into 2 times 4 is 8, minus 2 times minus 7 will give us 14. So let's solve this out. So this will be 1 into 21 minus 4 is 17, plus 3 into minus 6 minus 2 will be minus 6 plus 2, and that will give us minus 6 plus 2 is 4. Minus 6 plus 2 is minus 4. Minus 1 into 8 minus 14 will give us minus 6. So this will give us 1 times this is 17. 3 times minus 4 is minus 12. Minus 1 times minus 6 is plus 6. So when you solve this out, 17 minus 12 is 5 plus 6, 11. So our ay, that is our determinant for y, is 11. So far so good. We've gotten the determinant for y. So we'll go ahead to find the determinant for our z. We'll find determinant for z, and then we'll proceed. So in finding determinant for z, finding determinant for z, we say let AZ be the determinant. Let AZ be the determinant for Z. And so like I said earlier, so our AZ is going to be, okay, so to find our AZ now, determinant for Z, this is our X value, so we'll take it, we'll take our Y value, and since we are finding determinant for Z value, we'll replace this Z value with this. So let's take our X, 1, 2, minus 2, we take our Y, 2, minus 4, 2, and then we take our Z, because Z is what we are finding the determinant for, so we are going to replace it with this value. So we are not going to write this one, instead we'll bring this one and put it here. So we have minus 3, minus 7, 4. So having done this, we are set to find our determinant for Z. So AZ will be equal to, we take the first value, which is 1, and then if we take 1, we'll cover this, and then we'll cover this point. So we are going to be left with minus 4, 2, minus 7, 4, minus 7, and then 4. Okay, don't forget plus, minus, plus. So this will give us minus 2, and then means we'll have this, we'll cross here since we are looking at 2. So we are going to be left with, if we cross it, we are going to be left with 2, minus 2, minus 7, 4. Okay, we are done with that. We take minus 3. This is the one now we are looking at. So we take minus 3. So minus 3, we cross here, we cross here. So this will give us 2, minus 2, and then we have minus 4, and then 2. Okay, so having done that, we can solve it out now. And solve it out so that we have that this will multiply this, this, this. So this will be 1 into minus 4 times 4 will give us minus 16, minus 2 times minus 7 will give us minus 14, minus 2 into 2 times 4 is 8, minus 2 times minus 7 is minus 14, minus 3 into 2 times 2 times 2 is 4, 2 times 2 is 4, minus 2 times minus 4 is 8. Okay, so we continue. 1 into minus 16 minus minus 14 is the same thing as saying minus 16 plus 14. So this will be minus 16. Minus times minus is plus, so we have plus 14. Minus 2 into 8 minus minus 8. Okay. 8 minus 14 will give us 8 plus 14. I hope we are correct. Let me check where we had that is for 2. This is 2. 2 is 2 minus 2 minus 7, 4. Okay. All right. Minus 3 into 4 minus 8 will give us minus 4. Okay. So having done that, we'll have 1 into minus 16 plus 14 is minus 2. Minus 2 into sorry, I think is a minus 2 times minus 7 here is plus 14. Okay, plus 14. So here will be 8 minus 4, 14. So okay, yeah, thank you. 8 minus 14. So minus 2, 8 minus 14 will give us 6 here. Okay, 8 minus 14 is minus 6. Minus 3 into minus 4. So if we solve this, 1 times minus 2 is minus 2. Minus 2 times minus 6 is plus 12. And this minus 3 times minus 4 is plus 12 again. And so when you solve this out, minus 2 plus 12 is 10. 10 plus 12 will give us 22. So our AZ equal to 22. So we've gotten the determinant for the matrix, we've gotten the determinant for x, we've gotten the determinant for y, we've gotten the determinant for z. And so to find the value of our x now will be equal to the determinant of the determinant of x over a. Our y will be equal to the determinant of y over a, and our z will be equal to the determinant of z over a. So the determinant for our x was, let's check what we had as x. Was the determinant for x minus 66. So this is the determinant for our x, minus 66. So we have minus 66 divided by the determinant for our a is 22. So a is constant, is 22. So this 66 divided by 22, this is 1, this is 3. So minus 3. That's what the value of our x will be. So our determinant for y, what was the value? Okay, we have it here. The determinant for y is 11 and our x is 22. So 11 here 1, 11 here 2. So we have 1 over 2. And then our determinant for z was the value 22. See it here. Divided by our determinant for a, still 22. So we cancel 1, 1. So 1 divided by 1, 1. So we can now say, therefore, our x equal to minus 3, y equal to 1 over 2, and z equal to 1. So viewers, we've gotten to the end of this question. This is how to solve a system of equation using Cramer's rule. This is how to solve system of equation using Cramer's rule. So we started by first writing out the equation in form of matrix, and then first we had to find the determinant of the matrix. After finding the determinant of the matrix, we had to find the determinant of x. So this was how we were able to determine the determinant of x. And so I said, whenever you want to find for x, you replace x by the last value, the value in the right hand side. And so that was why we replaced it with this. Okay, and then I will go ahead to find the determinant for y, and so we replaced it with the value in the right hand side, and then we had to find the determinant for our z, determinant for our z, determinant for our z. After finding for y, we found for z also. So when we were done, we had to find the value of x by saying the determinant of x divided by the determinant of the matrix, which is A, and then for y divided by that of the matrix, and then for z, determinant of z divided by determinant of the matrix, and then we have this. Now, the truth is, if you slot in these values, that is -3, 1/2, and z in this equation, if you slot it into this equation, if you put x here, what is the value of x? The value of x is -3, yeah. If you put -3 here, and then the value of y here is what? 1/2, and then the value of z here is 1. If you write -3 plus 2 into 1/2 minus 1 here, it is going to give you this answer, which is -3. So once you're done solving your question and you want to find out if you're correct, you slot in the values of your x, y, and z to find out if it will give you this answer here, or you can slot it in the second equation to find out if it will give you the same answer here, or you can slot in the third equation to find out if it will give you the same answer here. So that's how to find out if you're correct. So viewers, basically this is how to solve system of equation using Cramer's rule. Thank you.